When I think about what features make a roller coaster exciting or thrilling, one of the things that comes to mind is max height. And I know that's one of the variables, so I'm just going to first start by taking a look at the distribution of max height. And actually, it's not what I was expecting at all. I was expecting more of a symmetric distribution where the there was like a cluster in the middle where most of the coasters have a max height somewhere in the middle. I wasn't expecting this cluster at the lower end of max height, and it wasn't, which leads to being a very skewed right distribution. And that is not at all what I was expecting. And so let me first make my graph a little bit bigger so that I can better see everything. But now let's go ahead and put some measures on. Because it is so skewed, I am not going to go ahead and put mean on at all. I'm just going to put my box plot, my median, and I'm going to go ahead and put some outliers because it is clear to me that we were going to have some outliers because we have these few that are really tall, and that doesn't surprise me. I was expecting that because you always have somebody push in the envelope trying to make it just a little bit taller, but it's hard to make really tall coasters, so I wasn't expecting tons of those. But I was very much thrown by this cluster. We're seeing somewhere around like in the like 10, around 10 to 15, somewhere in there. I wasn't expecting this cluster here. And in general, our typical, or our medians, so you could say our typical coaster, the max height is about 64 feet on coasters that are active in the US in spring of 2020. So that seems probably about right, about what I was expecting. And then what we notice is there's some variation here. Our middle 50%, the heights range from 28 feet, which I don't think of as all that tall, to about 109 feet. So that's pretty good range for a max height for those middle 50% of all our coasters. And so this wasn't exactly what I was expecting. I'm just curious. Wow, we have this one, tall outlier at 456 max feet. That's really tall. And then we got some others in the 400s, but we see we have quite a few outliers. So I was expecting some of these things, but some things surprised me. So the first thing I'm wondering about now is what explains this peak that surprised me? What's going on here? And so I wonder to myself if any of our other variables help explain that peak. Like, does a certain feature on a roller coaster lead to like it being very short? So something that jumps out at me is type, because maybe wood coasters can't be very tall. I don't know if that goes exactly with my experience, but it's something that I want to try. Ooh, it's the opposite of what I was thinking. I was thinking that wood is not as strong as steel, so they might be shorter, but what actually is happening is your shorter coasters are all, or mostly all steel. We have a few of the shorter coasters, but not very many of the shorter coasters are wood. How interesting. I wonder why that happens. That is not what I was expecting again. So I am going to leave just the median and box plots on this graph again. I am curious though. Let's add count. So there's so many more. There's 5 times the number of steel coasters as there are wood coasters. That's what I was expecting. And so, but that's still enough of each to feel comfortable doing a good comparison between these types for max height. And so the wood distribution was actually what I was expecting. It's much more symmetric, although it's still slightly skewed to the left, which is what I was expecting because I talked about having those few outliers of really tall coasters. But kind of the peak, you have one peak in the middle where you have a cluster around kind of somewhere in the middle of max height, somewhere in the 70s. And what we notice is that, so the median for wood is 82 feet, and the median for steel is lower at 54 feet. So on like the we can say a typical coaster, something that could be said is that wood typically is taller than steel, but that seems hard to say because we have so many steel that are taller than wood. Like for instance, the 75th percentile for wood. So 75% of the coasters are 99 feet or less. Whereas seven 75% of the coasters are 110 or less. So the variation in steel makes it hard to make that direct comparison and feel good about it. So for something, another good way to describe how the variation in wood is so much less. Wood's middle 50% range from 64 feet to 99 feet. So 50% of the coasters are between those two heights. Whereas steel's is such a large range. It ranges from 22 feet all the way up to 110.75, so 111 feet basically. And so there's just a lot more variation in steel. And so I'm wondering to myself if there's yet another variable that could help explain this peak that has me a little baffled, but also just help explain some of this variation we're seeing. And so I wonder, there's a few variables maybe we could think about, like maybe does like max height and duration, I'm not sure. Or maybe we could think about does maybe the scale here, like something that I'm thinking about right now, seeing this variable of scale, is the scale is kind of like your audience, right? Who was this coaster made for? Was it made for your family so everyone can enjoy? Was it made for little kids? And I'm wondering right now if this tall peak has something to do with like the audience, like who is supposed to be riding this coaster. And I quickly see when I add it on that a lot of this is these kiddie and family coasters, which makes a lot of sense. So that helps explain when you have different audiences and you're building a still roller coaster, but you have these different audiences, you're gonna have so much more variation in your max height. So what I wanna do is focus in, since we're talking about thrill, what I wanna do is focus in on just the extreme and thrill and see if there's a difference between wood and steel coaster. So let me hide selected cases for that. And then I'm also going to do the same with family, because family is what's making up that big peak. And so I'm going to hide selected cases again. Oh, interesting. So now I'm seeing more what I was expecting, but interestingly, I'm still seeing two peaks kind of in both, which is interesting. But you will notice, so steel just has more cases, and so you're going to consistently see more variation, right? But interestingly, steel now has a median of 100 feet. So it's a typical roller coaster is around 100 feet. And while it has two peaks, so you might want to also say that it has another one around in the lower 40s, that feels somewhat accurate, whereas woods feel pretty clustered there in the middle around 85 feet. So on average, steel roller coasters are now taller than wood roller coasters, and that feels about right. Also, what has flipped is your middle 50% of the wood all happen. So very interestingly, 75% of the coasters are shorter than 50% of the, I'm sorry, let me say that again. 75% of the wood coasters are at 100 feet or less, and 50% of the steel coasters are at 100 feet or more. And so it shows you that 75% of the wood coasters are shorter than 50% of the steel coasters. And so that this is more what I was expecting to see when I was originally graphing them. And so what my expectations fit these extreme and thrill, because that was how I was thinking about this and not the kitty, and those family coasters. So if we show all, so it's interesting how what we can really say is that the variation in steel is very much a product of the audience of the roller coaster, who they're expecting to ride it. And so that's something we can say.